How does engineers prevent buildings, most especially super tall structures, from swaying too much under strong wind forces and earthquake forces? Well, if you want to get an idea about this, then you should stick to the end of this video because we are going to be discussing the physics behind wind and earthquake building resistance, and also how engineers manage to control vibration on super tall structures. Before we continue, make sure to like this video, share with friends, and subscribe to my channel InnoTutorial for more construction videos like this. To start off, we should know that the higher and slimmer a building gets, the more they tend to sway at the top. On a typical winding day, a tower of 1,000 feet tall might move a couple of inches. Now, with all this slight movement, it doesn't mean the building will collapse or break down. But if it keeps moving couple of inches, it might result to serviceability issue, which can make the people living inside the building to panic. And as a structural engineer, we don't want such a scenario to occur because just as we focus on the structural strength, we also take serviceability aspect of the structure into account. So, because of this, engineers designing tiny and tall skyscrapers are now installing giant counterweights, or also known as damping systems, at the top of towers in order to offset or counteract building motions. One of these damping systems which is used on buildings is called a tune mass damper. This tune mass damper is made up of steel or concrete weighing anywhere from 300 to 800 tons. Let's see how this tune mass damper actually works. A tune mass damper is a mechanical device which is designed to add damping to a structure for a certain range of exciting frequencies. This extra damping will reduce the movement of the structure to an acceptable level. These dampers are connected to the structure walls by a system of pistons and spring mats. The damper acts almost similar to the shock absorber in your car. During high wind, it pulls the building back towards its original position. So, a tune mass damper contains a mass that is able to oscillate in the same direction as the structure. The oscillation frequency of the mass can be tuned using springs, suspension bars, or ball transfers. When the structure starts to oscillate, the mass of the tune mass damper will initially remain stationary due to inertia. A frictional or hydraulic component which is connected between the structure and the tune mass damper mass turns the kinetic energy of the structure into thermal energy, which results in a lower vibration amplitude of the structure. And the design of a tune mass damper will depend on the oscillation frequency, it will depend on the mass of the structure, it will depend on the direction of the movement, and also it will depend on the available space. So we can say a tune mass damper is a device mounted in large structures such as tall buildings and long bridges in order to reduce the amplitude of vibration caused by environmental forces. If you visit Taipei 101 skyscraper in Taiwan, you will see a giant golden ball which is placed beneath the observatory deck. This is the wind damper and it generates reaction forces to negate shock or vibration caused by outside forces, so that people inside the skyscraper can live and work in comfort without getting scared. These tune mass dampers are typically constructed of large steel bodies and mounted to move in an opposing direction to the oscillations of the structure. It is important that the vibrations caused by wind load and earthquake load on structures such as tall buildings and bridges be damped because it allows them to remain stable. And over the years, tune mass dampers in buildings and bridges have been responsible for keeping structures safe and also reducing the amount of damage which harsh weather conditions can wreak on those structures. If you also visit most skyscrapers today, skyscrapers such as the CN Tower in Toronto, the Crystal Tower in Osaka, the Center Point Tower in Sydney, and the Citicorp Center in New York, you will find many of these wind dampers, which are placed almost at the top of the skyscraper. So this is how engineers can use tune mass dampers to reduce vibrations on structures. If you found this video useful and informative, do not hesitate to like the video and subscribe to the channel InnoTutorial. And with that being said, you all have a good and a wonderful day. God bless you all. Bye bye.